Hello and welcome back. Today we're going to be tackling the following problem. If a skin diver takes a breath at the surface, filling his lungs with 5.82 liters of air, what volume will the air in his lungs occupy when he dives to a depth where the pressure is 1.92 atmospheres? Assume constant temperature and that the pressure at the surface is exactly 1 atmosphere. So we know what the initial pressure is, we know what the initial volume is, and we know what the final pressure is. So what we are currently trying to determine is what is our final volume. So this is Boyles Law. Remember, Boyles Law states that pressure and volume are indirectly proportional to one another. So if we are increasing our pressure, our volume must decrease. And this is how I want you to start looking at these problems in order to get an idea of where you need to start and if your final answer makes sense. So we know Boyles Law is pressure times volume is equal to our new pressure and our new volume. Well, we already know that we know our initial pressure and volume and our final pressure, so all we're doing is rearranging this equation for our final volume. So let me go ahead and rearrange that, and we'll have our final volume is equal to our initial pressure times our initial volume divided by our final pressure. Let's go ahead and plug everything into this problem. So we know P1 is 1 atmosphere. We know volume 1 is 5.82 liters. And we know our final pressure is 1.92 atmospheres. Atmosphere cancels out, and we end up with a final volume of 3.03 liters. This makes sense because our final volume is lower than our initial, and this makes sense because Boyles Law states that if you increase pressure, our volume must decrease in order to keep the temperature, the number of moles constant. Thank you for listening.